Algebra 3 Inequalities, Type 2 Quadratic Inequalities. So in the previous video we saw that with linear inequalities we solve them pretty much the same as a linear equation, except our answer is treated a little bit differently, especially if we're asked to draw on the number line. So here a quadratic inequality is going to be solved the same as solving a quadratic equation, but again how we treat the answer is going to be a little bit different. We're taking it one step further, and we have to make sure that we do not leave our answer in the form of x equals, which often happens. So our first example, solve x squared minus 7x plus 10 less than 0, where x is an element of the real numbers, and show the solution set on the number line. So we have to focus on the fact that this is less than 0, not less than or equal to, and also that x is an element of the real numbers, because that's going to be important for the number line. So let's take the quadratic, and the first thing I'm going to let it is we're going to solve it like it's an equation. So we're going to just pretend that it's equal to 0 for the purpose of finding the roots, in other words the two values for x. So if we look at what multiplies to give us 7 and adds to give us, what multiplies to give us 10 and adds to give us minus 7, well, it must be minus 5 and minus 2, because the two numbers must add to give us minus 7, but must multiply to give us plus 10. So grouping the first two and second two and taking out our highest common factor, we have x is common, leaving us with x minus 5. Minus 2 is common, leaving us with x minus 5. So our two brackets are the same, so therefore they are common. So if I take x minus 5 out as my highest common factor, well, that leaves me with x minus 2 equals 0. So by letting our factors equal 0, I get x minus 5 must equal 0, so x equals 5, or x minus 2 equals 0, so x equals 2. Now often students forget that this is an inequality and they think they're finished because they've got the two values for x, but again we draw our attention back up here to the fact that it was less than 0 to begin with. So we need to figure out, well, how do I figure out whether x is less than 5 or greater than 5, or x is less than 2 or greater than 2? So the easiest way to do this is to sketch our graph. So we're going to sketch the graph and then focus on the fact that the graph has to be less than 0. Okay, so if I've sketched the graph, I've figured out that the graph is going to cut the x-axis at the values x equals 5 and x equals 2. I can see that it is a positive x squared graph. In other words, the coefficient is plus 1. And therefore that gives us a U-shaped graph. So always make it a U-shaped graph. That's going to make your life much, much easier if we're always sketching a U-shaped graph. So that'll make it easier to remember how to write our answers. So if ever we have a negative coefficient in front of the x squared, multiply both sides across by minus 1, which obviously will then change your inequality sign also, and that'll give us our U-shaped graph. So we mark in 2 and 5. It's only a sketch. And I have to put an empty circle on 2 and 5, and that's because it is less than 0. Now, what does less than 0 mean? Well, less than 0 basically means that we're looking for where is the graph negative. And where is it negative? Well, it means where is the graph below the x-axis? Because that's where the y-coordinates will be negative. So if I'm looking what values of x make my y-coordinates below the x-axis, well, it must be any number between 2 and 5, because if I go to, say, 3 and I go down, my y-coordinate is negative. If I go to 4 and I go down, my y-coordinate is negative. If I've even gone 4.5, 4 3/4, in other words, all the values between 2 and 5 give me negative values for y. Where if I was going to the left of 2, I would get a positive y value. And if I was going to the right of 5, I would get a positive value for y. So how do we write the answer? Well, it means that x has to lie between 2 and 5, but cannot equal 2 or 5. So we say the answer is 2 is less than x, which is less than 5. In other words, x lies between 2 and 5. And of course, on the number line, then that would be 1, 2, 3, 4, and 5. If x is an element of the real numbers, then we're going to use our solid line. It cannot be equal to 2. It cannot be equal to 5. So we have empty circles. And there we go. That's our solution set on the number line. So in our second example here, we have to solve for minus 7x squared minus 21x less than or equal to 14, where x is an element of OR. This time we're not asked to show our solution set on the number line. So if I take my quadratic and I bring everything to the left-hand side, well, I have minus 7x squared minus 21x minus 14 is less than or equal to 0. We note that this is a negative coefficient, so that would give us an N-shaped graph, okay? And as I said in the previous example, we always want to make it a positive x squared just for ease of remembering how to write our solutions. So therefore we're going to multiply by minus 1, because that will make it a plus x squared, which then gives us our U shape. And then we'll base all our answers on this quadratic. So that would become 7x squared plus 21x plus 14. And of course, because I'm multiplying by a negative number, my inequality sign has to reverse. And 0 times minus 1 is still going to be 0. So now what we see is it's going to be greater than or equal to 0 when looking at the graph. So we're going to solve to find where does the graph cut the x-axis. So I'm going to let it equal to 0 just for the sake of solving our quadratic. I can also divide across here by 7. So therefore that's going to become x squared plus 3x plus 2 is equal to 0. Well, what multiplies to give us 2 and add to give us 3? Well, it must be 2 and 1. So that becomes x squared plus 2x plus x plus 2 equals 0. If I group the first two and the second two and take out the highest common factor, well, x is common between x squared and 2x, so that leaves me with x plus 1. 1 is common between x plus 2. And again, I can see, that should actually be a 2 there in the first bracket. So that's how you always know if you've made a mistake. So your two brackets here should always be the same because they need to be highest common factor. If they're not, go back and check your previous line. So then if x plus 2 is common, that leaves me with x plus 1 equals 0. So x plus 2 equals 0 gives me x equals minus 2. Or x plus 1 equals 0, so x equals minus 1. So again, we have to remember that this is an inequality, and therefore x equals minus 2 and x equals minus 1 is not our solution. Instead, we look at the graph. So the graph that we have to look at, we have made it 7x squared plus 21x plus 14 greater than or equal to 0, or x squared plus 3x plus 2 greater than or equal to 0. Doesn't make a difference what you're looking at, but it's greater than or equal to 0. It's a positive x squared coefficient, which gives us our U shape, and we're looking at it cutting the x-axis at minus 2 and minus 1. This time, because it's greater than or equal to, well, that means that it can equal minus 1 and it can equal minus 2, and therefore we fill in the circles where the graph cuts the x-axis. And because we're looking at greater than, well, greater than or equal to 0 means that the graph must be above the x-axis. Why? Well, it means that the y-coordinates are greater than or equal to 0. In other words, they are positive. So if the y-coordinates are positive, then that's the part of the graph that is above the x-axis. So what values of x gives us positive y coordinates? Well, it can't be between -2 and -1 this time, because if I go between -2 and -1, so minus 1.5, I would see that when x is -1.5, y is below the x-axis. So therefore, anything between -2 and -1 will give me a negative y coordinate. So therefore, that implies then I have to go to the right of -1 and to the left of -2, because that will give me all of these positive y coordinates. But it can also be at -2 and it can be at -1. And therefore our solution must be that if I'm going to the left of -2, x must be less than or equal to -2, or x is going to be greater than or equal to -1. So therefore that is my answer. So in general, if I have a U-shaped graph that cuts the x-axis at A and B, and I'm looking for less than or equal to 0, then the answer will always be x has to lie between these two numbers to give us a positive y value. In other words, our solution set will always be A less than or equal to x less than or equal to B. Where if we're looking at the graph, and again we have A and B is where it cuts the x-axis, and this time we're looking at greater than or equal to 0, then greater than or equal to 0 has to be to the left of B and to the left of A and to the right of B to give us all of those positive values for y, and therefore our answer will always be of the form x is less than or equal to A and x is greater than or equal to B. So by having that U-shaped graph all the time, and if we know what the graph looks like, then we know what our answer should always look like. Okay, so the last example we're going to look at is a word problem where it ends up being a quadratic inequality. So our last example is from Humphrey's textbook, where we're looking at a ball being thrown by a boy from the top of a building. So we're told that the ball leaves his hand 2 meters above the building. So that means this height here is 2 meters. And then the height reached by the ball above the ground after t seconds is given by h. So that means that at any point on the ball's projectile path will be represented by h. So obviously h is increasing as it's going up, and then h will decrease as it goes down until it hits the ground. So at this point h would equal 0, and then we can see it bounces and bounces and bounces until eventually it comes to a stop. So h is represented then by this equation here, where h is equal to 9 plus 8t minus t squared. We're also told that the height is in meters and that the time is in seconds. So the first thing it wants us to do is find the height of the building. So we can say, well, at the start, the time would be equal to 0 seconds. So by putting in t is 0 into our equation, well, that will give us the height above the ground, which is 9 meters. But of course, if we look at the start, where is the ball? The ball is in the boy's hand, so therefore that must be 2 meters plus the height of the building. So therefore, the height of the building, as opposed to the height of the ball above the ground, must be equal to 9 minus 2 meters, which is equal to 7 meters. So just be careful there. H is the height of the ball above the ground, whereas in the first part of the question, we're looking for the height of the building. So in part 2, we're looking for the time taken for the ball to hit the ground for the first time, because obviously we can see it bounces and bounces and bounces. So we're only looking for the first time it hits the ground. So what do we know when it hits the ground? Well, when the ball hits the ground, the height above the ground must be 0. So that means I can take the equation h equals 9 plus 8t minus t squared. And if I let h equal 0, well, what am I left with? I'm left with a quadratic. So let's just rearrange that by multiplying across by minus 1. So if I multiply minus t squared by minus 1, I get plus t squared. Then I'll get minus 8t minus 9. And now we can see it more clearly that it is definitely a quadratic. So what multiplies to give us minus 9? That has to give us minus 8. Well, it must be minus 9 plus 1. So if I put that in, I have t squared minus 9t plus t minus 9 equals 0. Take out the first two highest common factor and the second two highest common factor. Well, t is common, leaving me with t minus 9. 1 is common, leaving me with t minus 9. And then both of these brackets are the same. So therefore my highest common factor is t minus 9, leaving me with t plus 1 equals 0. So therefore t must equal, t minus 9 equals 0, so t must equal 9. Or t plus 1 equals 0, leaving me with t is equal to minus 1. But we have to think about this because this is in context. I cannot have a negative time. So therefore my answer must be the ball hits the ground after 9 seconds. So because this is a question in context, we have to have units in our answer. Otherwise we would lose marks in the leave insert. And we have to apply our common sense here. In other words, that we can't have the negative time. So if we go back to the question, the third part then says find the range of values for which the ball is less than 21 meters above the ground. So this is your hint, okay? When it's an equation, it would say solve, but when it's an inequality, it'll say range. So range implies inequality. And how do I set up the inequality? Well, the word that's here is less than. It doesn't say less than or equal to, it says less than. So our inequality then is going to become h, the height, is less than 21 meters. But we know that h is 9 plus 8t minus t squared. So that means that has to be less than 21. So if I bring everything to one side, in other words, subtract 21 from both sides, I get 9 minus 21 plus 8t minus t squared is less than 0. In other words, minus t squared plus 8t minus 12 is less than 0. But of course, we know if we're going to sketch our graph, we always want a positive t squared to get that U shape. So I'm going to multiply everything across by minus 1. So minus 1 times minus t squared is plus t squared. Then we get minus 8t. Minus 1 times minus 12 is plus 12. And of course, because I'm multiplying by a minus 1, my inequality sign has to reverse. And 0 times minus 1 is 0. So therefore now we see that it is greater than 0. So we're looking for above the x-axis. It's a positive t squared. So therefore it's going to be a U-shaped graph. So we need to know, well, where does the graph cut the x-axis? So we're going to just let this inequality equal 0 just so I can find those roots. In other words, where it cuts the x-axis. So factors that multiply to give you 12 and add to give you minus 8 must be minus 6 and minus 2. So that's t squared minus 6t minus 2t plus 12 equals 0. Take out the highest common factor between the first two and the second two. So that gives me t minus 6. And then take out minus 2, which gives me again t minus 6. So these brackets are the same. So therefore my highest common factor is going to be t minus 6. That leaves me with t minus 2 is equal to 0. So t minus 6 equals 0 gives me t equals 6. or t minus 2 equals 0 gives me t equals 2. So is this possible? The last time we only accepted one of these answers. So is it possible for it to be less than 21 meters above the ground? Well, let's go back to the diagram. Of course, the highest point reached must be greater than 21 meters. And of course, if I go across here, yes, there are two possible times that I could get the ball less than 21 meters. So here we would have the first time, and here we would have the second time. So of course we need to look at the range of answers. So to get the range, we need to sketch our graph. And our graph is for t squared minus 8t plus 12. And it's greater than 0. So greater than 0 means above the x-axis. In other words, where are my y-coordinates of this graph? Positive. So our two values there were 6 and 2. Greater than, so I can't fill in those circles. Must be empty circles. Above the x-axis, well, that implies that I'm going to the left of 2 to get positive answers, and I'm going to the right of 6 to get positive answers. So what that implies then is that the time has to be less than 2 seconds, or the time has to be greater than 6 seconds. But what do we know? We know it hits the ground When does it hit the ground? It hits the ground for the first time at 9 seconds. So, of course, I can't have time equals 0 or less than 0. So, therefore, it must be 0 is less than t. It can be equal to t and less than 2. And again, if we were just looking at it between the first bounce, so when is it less than 21 meters the first time it hits the ground? In that case, then we would say 6 is less than t, which is less than or equal to 9. And again, we put in seconds in our answer. So if you go to your books, page 73, you're then going to do question 19, 20, and 21, which is our quadratic inequalities in word problem form. And then the basic quadratic inequalities was page 72, question 1 to 5, 8 and 9.